Okay, hello Cloud Gurus, and welcome to this first lecture on the different services in the Google Cloud Platform. In this lecture, we're going to take a look at the compute-oriented GCP services. First up is the Google Compute Engine, or GCE. This is a zonal service, and it lets you rent virtual machines on demand. Now, those machines start off with nothing more than the operating system on them, but you can install whatever software you want and use them however you want. You could run them as a web server or a database server, do machine learning on them, run analytics processing. You could even play video games on them if you really wanted to. This is infrastructure as a service, and it's quite similar to Amazon Web Services' EC2 service. The closest thing you'd probably get to this in your own data center would be some VMware product. Google has really optimized the performance of these machines, and they say that they boot up on average in only 35 seconds. Now, depending on how powerful you need these machines to be, you can choose from a number of pre-configured instance types. But an interesting thing about GCE is that you can actually customize exactly how many CPUs you want and how much RAM you need, even if that particular configuration would fall in between some pre-configured types. Now, whatever number of CPUs and however much RAM you do wind up with, you'll pay by the second for it, with a 1-minute minimum. Of course, as usual, you'll also pay by the gigabyte for network traffic leaving the zone or region, but that's not specific to this service. Now, an interesting thing about GCE is that they automatically get cheaper if you keep running them. This is what they call the sustained use discount. Of course, in absolute dollars, the less you run it, the cheaper it is, and you can just keep turning them on and off depending on your load. But it is kind of nice to know that if you just keep them going, they automatically get cheaper. And for what it's worth, this isn't a specific instance that has to be running the entire time either. It's a lot more flexible than that. Now, the cost per hour, or per second if you will, gets even cheaper if you tell Google that your instance is preemptible. That is, turn it off whenever they need that particular resource back. Or if you commit to a long-term usage in a particular region. The long-term usage discount is quite similar to AWS's flexible reserved instances, and the preemptible instances are similar to AWS's spot market, although Google's pricing is rather simpler and not an auction, so you know upfront what you'll pay. The base cost for one of these instances is based on running a free Linux operating system, but you can pay extra to run Windows or Red Hat Enterprise Linux or something like that. You can also add GPUs for an extra cost to really boost the capability. Now, there's a ton more to say about this service, but I'm trying to keep this introduction at a high level. So if you want to read more, you can go ahead and scan this QR code or follow the link in the resources section. Next up, we have Google Kubernetes Engine, or GKE. This offers a managed Kubernetes cluster for running Docker containers, and it includes auto-scaling. Now, up until November of 2017, this used to be called the Google Container Engine, still with the GKE abbreviation. But I think that Google might have decided that Kubernetes was now well enough known to become a part of the name of the service itself. Interestingly, Kubernetes was actually released by Google as an open source project a number of years ago, and it was based on their internal tool called Borg that they'd been using for many years before that. How this service works is that you'll create a GKE cluster in a particular region, and it will then create GCE instances for you in the different zones in that region. At that point, you'll give it whatever containers you want and some instructions around them, and it will put those containers on those different instances automatically for you. If load on your system goes up and you'll need more containers, well, it can just automatically add more containers for you. The containers themselves can do whatever you want them to do, as long as you can package that up in a Docker container. Now, given that it's all about managing containers running on instances, this compares quite directly to AWS's EC2 Container Service, or ECS, and even more so now that Amazon has their own Kubernetes-based container management that they dub EKS. And if you were doing this on your own, you might use Docker and orchestrate it yourself, or use something like Docker Swarm. GKE has the Kubernetes DNS service on by default for service discovery, so you don't have to worry about using something like Consul. But unlike Amazon's ECS, this doesn't integrate directly with IAM, the Identity and Access Management Service. So if you want these containers to use other GCP services, you'll have to manage those credentials and secrets more manually. That said, GKE does integrate automatically with Persistent Disk for storage, which is a service that we'll cover later on. Now, the pricing for GKE is actually a lot simpler than it used to be. When you create a cluster, it'll automatically create GCE instances for you, and you pay for those directly. And if you're considering using this service, you should know that a production cluster should generally have 3 or more nodes so that it can handle failures robustly. Now, Google used to charge an extra fee if you had a cluster that was over a certain number of nodes, but they eliminated that fee in November of 2017. Now this is barely even scratching the surface on GKE. There's a lot here, both in terms of what Kubernetes offers by itself and in terms of what GKE does. Next up, we have the Google App Engine. GAE is a platform as a service that'll take your code and run it in whichever region you've chosen. This is arguably closest to Elastic Beanstalk in the AWS world, or Heroku outside of it. But in any case, there's a lot more to App Engine than just compute. It really is a platform for application development. Natively, App Engine supports the Java, Python, PHP, and Go programming languages, but it also has an App Engine Flex mode that can run any container you give it. So in that way, it can support pretty much any language. So for example, I saw the Stack Overflow famous John Skeet speak at Google Next about running C# applications in App Engine Flex. All the Google Next videos are now available to watch for free on YouTube, so you can find the talk there if that interests you. Regardless of whether you're giving it code or containers, it'll auto-scale based on the load, and it can even scale down to 0 if you get no traffic. For this service, you effectively pay for the underlying instances, although it's a bit more complicated than that. Last but not least, we have Google Cloud Functions. These will run Node.js code in response to a particular event. It can be possible to run other code in Cloud Functions, but you'll need to have a Node.js-based shim that translates to the other language for you. I've seen that people have already made shims for Python and Go, but you could make one for whatever language you want. Cloud Functions are what are known as functions as a service, and although it's not exactly the same thing, people often refer to this just as serverless. This service is very much like AWS's Lambda service. A really interesting thing about Cloud Functions is that you don't have to provision a certain amount of capability and pay for that. You only pay when the function actually gets run, and you only pay for however long it runs in 100 millisecond blocks, depending on how much CPU capability and RAM you assign to that particular function. One differentiator for Cloud Functions is that every function automatically gets an HTTP endpoint, so you can trigger Cloud Functions without having to set up a separate API gateway. You can also trigger Cloud Functions based on Google Cloud Storage objects, pub/sub messages, and a bunch of other things. Because you're not responsible for this scaling, Google can automatically scale this massively for you. If your system gets a flood of new events, Cloud Functions can just drop your code onto a whole bunch of different machines to handle the load. Well, we're really just getting started with these services, so you might want to go and grab a cup of coffee or something, but if you have any questions for me, please do let me know. If not, please feel free to move on to the next lecture. Thank you.